that recording. I'm going to start recording here. 1188 will drive sealed lead acid batteries or VRLA. 450 will be vetted lead acid, and then you get the NICAD testing. So all those regulations and requirements that are put in there, we try to build that around our battery monitor. A couple of years back, probably, I think this is probably about 12 years old, is IEEE 1491, which is all based around battery monitoring. So how to build a better, battery monitor. There's a lot of items in there. Honestly, if you put every single item in there, your battery monitor would probably get more expensive than your battery. So what we try to do is just kind of give the key points, the key metrics to kind of tell you things are good and bad when it's related to battery monitoring. So some of the things that are in there are going to be voltage, jar, or cell, or even string voltage. You want to grab that measurement, the connection resistance, the coup de foi. You want to see when that discharge happens, if it's kind of snapping back, that whiplash effect you get after a discharge. Any cell or resistance, ohmic value, temperature per jar or cell, electrolyte level, discharge. If it's getting those discharge values when they're charging and discharging, see how the system responds, the battery system responds during those conditions. Specific gravity is on there as well, but I kind of exit off because we don't provide that as far as Generex. It becomes a pretty costly solution when you're dealing with the flooded product because there's so many cells. You need a lot of different sensors and meters for that. And then what you're going to see, if there's any kind of specific gravity issues, a lot of times you see it in the voltage measurement as well. So that being said, battery monitoring is one thing. We want to talk about true battery management, and kind of we're going to break it down into this triangle of all the components. So what makes up a battery management system is going to be a couple of things, and there's actually probably 4 pillars, but we just the triangle looks better, so we're going to go with just 3 today. So what makes the battery management system is you're going to have a monitor. Okay, a monitor is going to be put on there, and that's going to bring in those types of features. Then you want the maintenance feature. You want to maintain with your battery management system. So that's just another item that you want to add on there. And lastly, you want to protect. Protect all your systems there. So how that kind of works out is when you're monitoring, you want to see the state of health of the battery and the operating environment. So most battery monitors do that, whether whatever brand you decide to choose as far as a monitor, they do that pretty well. Whether it's Albert, Cellwatch, VTech, they do that pretty well, and they monitor your operating conditions. The maintaining part is you want your battery management system to maintain a specified or a balanced voltage. Okay, and that's huge in keeping your batteries at the right low voltage level, and that's going to push out the higher capacity and the longer service life. That's a key feature in battery management. Okay, and then lastly is you want to protect a couple of things. We want to think about the engineering side of it. You want to protect your batteries from over and under charging. You want to protect thermal runaway, and then you want to protect the critical load, whatever it is. These battery systems are backing up data centers. They're backing up utility systems, whatever kind of your business is, business is maintain or its metric of success. We want to back up that critical load, and then we want to provide you a decent system that's going to monitor and maintain your batteries so that your critical load is protected. And bottom line, due to the longer service life, it's going to protect your capital expense. So right now, with a standard battery monitor, the batteries really turn into a consumable. It's something that you're going to replace at a certain cycle. Let's treat it as an asset and kind of push out, really use your capital expense. So those are the three items for battery management, or three pillars. Another thing to be said is, as long as the maintenance aspect is the, voltage balancing. Balancing could be the other pillar. A lot of the battery monitors get a lot of over and undercharging voltage alarms, and there's really nothing you can do about it when you're monitoring it. It'll kind of alert you of it. A battery management system will see those over under voltages, make the necessary corrections to kind of keep it in that balance, so you're not getting those nuisance alarms. And then a lot of times when that happens, your battery monitor turns into a boat anchor, and nobody wants to respond to every little thing that's getting pushed out. Right. So when we talk about design life and service life, it's a common question that gets put out there, and they kind of get mixed together. When somebody asks, hey, what's the design life of your battery? People typically say, well, if you look at a standard 12-volt VRLA, they typically would say 5 years. And that's actually the service life. So if we took a deeper look at the battery data sheet, you'll hear a design life of 10 years for the typical VRLA product, or 20 years for the vented lead acid. And there's some VRLA product that is also 20 years. It's just based on that design. So typically what's happened is that 10-year, actually the EnerSys is pushing out a 10 to 12-year design. Typically the service life is about 50 to 60% of that. And that's all going to be based on a couple of things, flow voltage being one of it, but there's a number of items about that. So there's a lot of misconceptions of, hey, this is a 20-year design life, but I know I'm going to get 12 or 15, in that mix up. So, why the battery manufacturers kind of push that out, and some of the reasons is the design life is calculated that high is a lot of times these batteries are put in like a perfect environment. They're single source charged, so they have the exact flow voltage the whole time of its design life period. Sometimes it's calculated that way based on the materials they use to put together the chemistries and the electrochemical process, the electrochemical process. It's in a very controlled environment too, so it's at a pristine, 25 degrees Celsius, 77 degrees Fahrenheit, and it's never cycled. So that's why that design life is so much longer. When we take it into the real world applications, that's a lot of the things. The application can be the problem. You know what I mean? You have one overall charger charging multiple cells, multiple batteries that are made up of multiple cells, and the slightest little differences in the electrochemical processes can make those batteries not charge properly, and you'll get those huge voltage deviations. You also get uncontrolled environments. In a data center, that's cooling is kind of is a tough thing, and it's one of the things that get pushed out the most because there's a lot of mechanical failures, and so there's a lot of redundancy. So getting the right temperatures in your battery room is kind of a second thought. So sometimes it's too high, sometimes it's too low. If the temperature is too high, you are going to affect the health of your battery and their service life. If it's too low, you also lose. You may maintain a longer service life, but you're going to lose capacity if it's too cold. So kind of the batteries are kind of a sensitive subject, you know what I mean? So, and then a lot of times they get overcycled, too many discharges. And this would be maybe in just areas where there is a lot of outages and things like that. But typically what I've seen is, I think the cycle rate is, they're never overcycled too much. I mean, you can have the rare instance where they do. You could have some sizing issues with the UPS or rectifier system where that UPS cannot keep up with the load, and even though they're doing load steps, they can't. It's pulling on the batteries each time. So another service life effect that it has affected is low or no maintenance. When the VRLA battery came out, it was called a maintenance-free battery. You didn't have to fill it, but we still know we have to have some kind of maintenance application, either on a quarterly or a semi-annual basis. If you're not doing anything, you can run into those problems and not even know. So, and battery problems are still, when we talk about the data center environment, are still the number one cause of unplanned outages, are due to battery failure. Still 29%, 24% is human or accidental error. So they need a high level of maintenance, and they need to be managed properly, to be honest. So some of the battery failure modes that you can kind of see on the bottom is you got positive grid corrosion, sulfation, dryout, and thermal runaway. The next modes are installation errors, excessive cycling, temperature effects, and manufacturing defects. Those are the other ones that can kind of cause those problems. You do see the installation errors and the manufacturing defects. You will see those on an infant stage. You'll probably see them right away when you're kind of doing your battery system commissioning. Excessive cycling and the temperature kind of come over time. You have, the failure modes that were kind of carved off to the left there that are kind of highlighted in red. Positive grid corrosion, sulfation, dryout, and thermal runaway are heavily due to how those batteries are charged. So we're going to look at the voltage portion of it. So if the voltage is too high, you get that positive grid corrosion, building up and causing that dryout as well. That can happen. If the batteries are charged too low, you get sulfation. Okay, and then the result of too much dryout is thermal runaway. So that's kind of why we carved it out that way. So if you have a battery management system that is monitoring your temperature, it's controlling over and undercharging, and it's seeing, it's detecting the manufacturing defects in the early stage, you're kind of covering your bases as to why batteries fail. And I owe it to four things when batteries fail: overcharging, undercharging, manufacturing defects, and temperature. So you're controlling two, you're monitoring the third. Manufacturing defects we can't do anything about, but we will really see it in the early stage with a good battery management system on board. So why, we just talked about voltage, why is voltage so important? I believe it's the key to everything. So what you can kind of see on the top there, I kind of gave some general float specs per cell for all the batteries that are out there, whether it's C&D, East Penn, Enersys, CSB. I didn't want to throw anybody on the bus, but they developed their float spec, and it's all based on this. It's J.J. Lander who kind of developed this curve and this measurement technique. So what they do is, you can kind of see the small window on the bottom. They actually measure from the separator to the positive post, and they're looking for that plate polarization level. So when they're designing or specifying their float spec for their battery, they look at those values. So as their batteries start to get overcharged, you can kind of see this is your corrosion rate. So way overcharged, you're getting a high level of corrosion. Way undercharged or open circuit, you're still going to get a high level of corrosion. This is like the sweet spot, and this number of this float spec reflects that little sweet spot. So if they stay in that range, they minimize the corrosion rate of the batteries. The neat part about that is what a battery management system tries to do is try to hold those values. So each battery within those float specification values. When you're setting up your UPS or charging system, you're basing that overall total voltage on the number of cells, so you can kind of get that sweet spot right there. But what happens is, because you have one overall charger, there's no way to have every single battery exact without a battery management system on board. So voltage is very important, and then we can go back to all of our IEEE standards that talk about, hey, if you want to protect your batteries, do this. Like it says in IEEE 1491, you're going to have low voltages, you're going to have sulfation occurring, you're going to have a accelerated corrosion rate, you're going to have a lower runtime or capacity. And then if you have higher, you have potential the same thing: accelerated grid corrosion, gassing, thermal runaway, and again, a premature, lower service life. So, and then this is what typically happens. So you have one overall charger, and you have large levels, voltage level deviations. And this is kind of what we saw. I think Tim said we have a new technology, but we started investigating building a battery management system back in 2004, and just kind of slowly improved it over time. We didn't love the fact is, you have a monitor that would just be alerting at all these levels instead of making the necessary corrections. So all these would be out of specification, either overcharging or undercharging, and there's nothing you could do when you had one overall charger. When you have a battery management system on board, it levels those things out so everything will maintain, the batteries within the float specification. So you'll get something like this next slide. So basically, the battery management system is turned off at this period, and it starts establishing, and every single unit is brought within the recommended float specs. So if you wanted to get into warranty issues with battery manufacturers, they could probably prorate your warranty because, hey, you didn't maintain your batteries within our float specification. That is built into their warranties. If you looked a little deeper, they could ding the user on not maintaining a float specification. If you don't have a battery management system on board, there's no way to maintain that float specification. So, and then this is a neat slide. When you're looking at the voltage balancing or conditioning, you're saving money and you're extending life when those batteries are balanced. And you get into those zones where you have the potential of overcharging, undercharging, lower capacity. When they're getting overcharged, you have the potential for thermal runaways as well. So again, back to 1491, it definitely will increase. Monitoring does help, right? It's a complete luxury to have a monitor on board. Right now, if you don't have monitoring, I think for the data centers, the SEC requirement is quarterly battery PM. If you had a decent service group that's coming in quarterly, trending your battery data, maintaining your system. Again, that same personnel, that same traditional maintenance, if they saw any high or low voltages, they just kind of mark it off on the report. There's no corrections they could make. That's typically what would happen with the battery monitor. It will basically tell you, hey, you got a high voltage or low voltage. The impedances, the ohmic values look fine, but we'll alert you of it. But there's nothing we can maintain or change about that. So, and again, like I said, there's nothing wrong with battery monitoring. Is a part of a battery management system, but you can't really classify yourself as a battery management system if you're not making the necessary corrections. Okay. Again, float specifications is all in our IEEE guideline. And what we want to see is, if we wanted to have, if we saw lower than specified voltage, why not have a system that says, hey, every float voltage can be managed or should be managed? Basically update this standard to say, we want to have our float voltage managed through a battery management system. So every single jar is charged properly. And then what you're going to see is, again, no undercharge and no overcharged batteries. You'll see a longer service life, a higher capacity. You'll actually get a better impedance or ohmic value measurement, because that value is heavily influenced of what your float voltage is. And a huge cost savings, because you're able to extend that service life from 5 to 6 years to 7 and 8. And that's, that's a huge cost savings when it comes down to it. The biggest thing we want to do is kind of just keep those batteries out of those dry outs and those sulfation zones. I came from the nuclear power industry, and the biggest way to minimize your exposure to radiation is to stay away from it. You know what I mean? So if we keep those batteries away from those dry out zones and the sulfation zones, you're going to optimize your battery system, optimize your capital expenses, and then increase your reliability of your battery systems, because again, you're keeping the batteries at pristine value, and this is going to increase your reliability of your critical operation. So, and then here's some quick just some return on investment details for the financial aspect, and it's taken into account there's about 3,200 batteries at about $259 each. What you're going to see is you'll see a return on investment in less than 3 years. We do have a battery replacement in that 10-year cycle versus the 2 and 3 that you would have without a battery management system on board. For even a small amount of batteries over that 10-year period, you're going to see a net savings of almost like 1.1 million. So we have some customers that have 3,200 batteries is almost a quarter of their site. They might have quadruple the amount of batteries in the site. So again, you see a huge cost savings when it comes into fact of that. So kind of wrapping up, this is kind of some Q&A time. So if you guys want to unmute, that's fine. But we have a couple of questions here that kind of got added, but I would like to take everybody's questions first, and then we can pull from this. The one thing I can answer, can you make your CFO happy? If it's free, maybe, but I don't know if you can ever do that. So, but we'll open up this time for questions. If you guys need me to backtrack or review any other slides, we can do that as well. I think some people joined a little later, so I'll open it up. Anyone?
Hey, Dan, have there been any white papers that have been written on the Generex that that have a history and some time frame behind them to discuss what we've been talking about?
That's a great question. So yeah, we participated in a couple of white papers. We kind of had to sanitize some of the end users. One of the white papers we wrote was, I think it was something like design life versus service life, and it's all about the charging. It was co-authored by one of our end users based on their data and the results. And without kind of mentioning the end user, again, to kind of tell the story is they were, I don't want to say suspect, but I guess they were suspect of, they had been using battery monitoring for a number of years, probably gone through the gauntlet of every different battery monitoring manufacturer. They put the Generex system to a test where they put the batteries on, they put the Generex back system on 5-year-old 12-volt VRLA batteries. They had 2 different UPS systems. I believe the UPS systems were made up of 2 strings each. They left the system on there for about 2 years. So, right, we installed it the 5-year period, which is that's that service life. So they would actually they needed to be replaced. The Generex system was able to find some defective batteries in there, and they were able to, because you had a battery management system on board, be able to mix the old batteries with the new batteries without the jar interaction. At the end of the 7 years, they did a full discharge test, and the batteries were at 100% capacity. So they kind of made their, I guess their stamp of approval on the Generex system, and that is their, default standard for how they deploy battery systems. They'll deploy a battery system with a 10-year design and take it to 8 years and replace it then. And then at a 16-year total, they're going to renew the battery system and the UPS together. So that was one case, white paper we wrote. We wrote another one regarding lithium and lead acid, and how we've actually been able to take the lead acid product and kind of improve on, enhance it, and make sure, make it compete with lithium. Because again, I think lithium already has built-in battery management systems. Maybe that's some of the reasons why it lasts longer as well. So we kind of compared those two, because we've gotten a pretty good return on the customer's investment using a lead solution. And then if the benefits are, you're getting that, and you're getting, I guess, all the horror stories you hear with lithium with fires. And I think they're lithium people are going with safe chemistries. But there's still that risk that there's the unknown factor of it. It hasn't really been proven, where lead does have a pretty good safety history. Let's put a battery management system up over lead and extend that and take that a little bit further to kind of, lower the costs and keep the market pretty competitive. So, and the last thing we're kind of working on is that this 4 pillars of battery management. So that's kind of in progress, but that's kind of the papers we worked on. There's a number of third-party papers to kind of, beat this horse dead on life extension through voltage balancing or equalization. So a couple of universities had written some, I think it was University of Illinois, it's a Philip Kren had taken write a couple white papers on seeing life extension and high availability and using the voltage balancing technology. Any other questions?
Yeah, hello, Daniel.
Yes, sir.
Yeah, you mentioned float specification.
Yes, sir.
Yeah, can you compute it if you don't know, or if the manufacturer that didn't state the float specification, can you compute it, and how do you compute it?
So when they do the float specification, I'll kind of backtrack. Typically, what those battery manufacturers will use is the Landers curve technique to build their float specification. And this is early in their development. They'll kind of put their formation technology, their plate technology, and they'll develop their float spec based on what they're seeing from those values. So they do take a measurement from the separator to the positive post, and what you want to see is a value between 70 and 80 millivolts. That'll minimize those corrosion rates, and that's how they develop their float specification. They kind of only do that once, the development of the battery, and then they, again, the process is built, everything's built, and that's how they built. They keep to that specification. They don't do it each and every time they build a battery. They kind of build that spec in the beginning. So, but typically the magic number is, for most of the batteries, it's the ideal float spec is about 2.25 volts per cell. So.
Oh, okay. 2.25
okay.
volts. All right.
Yep.
My last question. Hello, Daniel.
Yes, I'm still here.
Yeah. Can we get the PDF copy of your presentation?
Absolutely. I think Tim and Carolyn have your contact information, and they'll get you that. And I think we're recording this as well, so you can hear my bad presentation again as much as you want. And then you can always review it and go back and see all this stuff.
Okay. Thank you very much. All right.
Sure,
thank you
for joining us.
All right.
Any other questions, comments? Tim, do you have anything to add?
No, except that we'll post. This will actually be on our website, posted under our blogs, and then we'll also send this presentation back out to everyone who joined us and so that they can review it. And I thank everybody for joining us. And Dan, it was very well done. It was a really very informative presentation.
Okay. All right. So if there's no other questions, you know, just to kind of breeze through these, some of these questions is, you know, we can do more than a standard monitor. So be watchful of, you know, I guess be watchful of what you know, if you're looking at battery monitoring and like that. You know, a lot of my competitors are calling themselves battery management systems. Just if they're starting to do the balancing and the maintaining the voltage levels, then we finally have some competition. But I think a true battery management system is more of a need than a luxury of like a battery monitor. So, and then we're definitely seeing the fruits of getting longer service life. You're proving that, you know, you're turning those batteries into assets, and it's going to save you, you know, you and the end users a lot of money. So that's it. That's all I got.
All right. Well, thank you very much, Dan. Thanks everybody for joining us. And again, if you have any questions you think about later, you know, you can reach out to T. Wilson at ptisolutions.com, and we'll get back to you as soon as we can and answer your questions. Again, I thank you for joining us, and everyone have a nice day.
All right. Thank you very much. Thank you.